Chem 1A, this is Chapter 4, Lecture Video 3, and we're going to be talking about aqueous solutions. So, a big part of the reactions that we do in general chemistry are aqueous reactions. So we need to talk about solutions. Solutions are a mixture. Typically, when we think of solutions, we always think of a homogeneous mixture. And we have some vocab words that come with a solution. A solution contains both a solute and a solvent. Usually when we mix two substances together in a solution, one of them is the majority component and the other is the minority component, the component that there's less of. So the solute is always the substance we do not have as much of in the solution. It's usually the thing that is being dissolved. There's less of it present in the overall solution. The solvent is that which does the dissolving. It dissolves the solute and is generally in a larger amount. Most solutions we work with in general chemistry are what we call aqueous solutions, meaning the solvent is water for aqueous solutions. And so this is kind of an idea of an aqueous solution right here. We have copper 2 sulfate dissolved in water, and this is a concentration unit we'll talk about later. So let's talk a little bit more about aqueous solutions. Now, when we talk about solutes, again, they are homogeneous mixtures where water is the solvent. The solute, we can group aqueous solution solutes into one of two main categories. I should use a different color here. Electrolytes versus non-electrolytes. Now, an electrolyte is a substance that when it dissolves in water, breaks apart into ions. Now, all ionic compounds are what we call electrolytes. These are things that, for instance, if I dissolve sodium chloride in water, it will break apart into Na plus and Cl minus, the two ions that make up sodium chloride. This is what it means to be an electrolyte. When something dissolved in water immediately will break up into the ions that make it up, this is an electrolyte. Strong electrolytes have a very specific meaning. So this word strong here means something very specific. It means that 100% of the substance breaks up into those ions. For instance, NaCl is actually a strong electrolyte. Just kind of abbreviate that. So what that means is if I add 100 grams of NaCl, all of it will go to being ions once it's dissolved. Not some of it, all of it. Weak electrolytes are things that only some of it actually ionizes, maybe 50% or less. All right. This brings us to the complete opposite scenario. Non-electrolytes generally are molecular compounds, and when we dissolve them in water, nothing happens. They don't break up into ions. For instance, sucrose is a sugar. It's C12H22O11, I believe. And when we dissolve it in water, it just stays C12H22O11. Very soluble. It still dissolves readily, sugar, right? But it's not breaking apart into ions because it's not made up of ions. Okay, so one of the things you're going to need to be able to do is look at a solute and determine whether that solute is going to be a strong electrolyte, a weak electrolyte, or a non-electrolyte. And so this is one of the more bigger struggles for sure in this chapter that students face. Now, the first step in trying to figure this out is really identifying what type of compound we're dealing with. Is the compound an ionic compound or a molecular compound? And we learned how to do this in Chapter 3 in the last tests material. And if you can't do that, then this is going to be very difficult to correctly determine whether a substance is an electrolyte or not. After you know it's an ionic compound, pretty much all ionic compounds are strong electrolytes. There is one exception, and that is if it's not soluble. So our ionic compounds have to be soluble in order to be strong electrolytes. If our ionic compound is not soluble, then it's not a strong electrolyte, but it's still an electrolyte. It's just a weak electrolyte. So we'll talk about how to determine whether an ionic compound is soluble or not in just a second. But if it isn't a soluble ionic compound, it's going to be considered a weak electrolyte. If it is a soluble ionic compound, it's a strong electrolyte. And that's pretty straightforward. When we talk about the molecular compound group, that's where things get a bit confusing. All acids, and we're not going to discuss weak bases, so in this class, that's something that'll be covered in Chem 1B extensively. So we're just going to focus primarily on acids. Molecular compounds can be broken down into pretty much every other molecular compound and acids. Now, if we have a strong acid, that means it's a strong electrolyte. If we have a weak acid, it means it's a weak electrolyte. And so you should be able to identify acids by now because we talked about them quite a bit in chapter 3 with naming them and all that. How do we distinguish between a strong acid and a weak acid? Well, we memorize the strong acids, and then that way we can know anything that's not one of these things we memorized is a weak acid. Anything that is one of these things we memorized is a strong acid. Now we'll talk about what acids we need to memorize and all that in a bit. Pretty much all other molecular compounds are non-electrolytes. So really it's just acids that make this a little bit more tricky. Whether your acid is a strong electrolyte or a weak electrolyte is dependent on its strength. Okay, conductivity. So when we dissolve stuff in water, one of the common misconceptions about water is actually a insulator, not a conductor of electricity. A lot of people think, oh, water will conduct electricity, and if you step into something that has a live wire attached to it, and it's in water, and you step on the water, you'll get electrocuted or shocked, right? That's true, maybe, but that's actually because of the stuff that's dissolved in water, not because of water's conducting the electricity itself. If you have pure water by itself, nothing dissolved in it, then you put that electrical cord in the water, you could step in, you'd be fine, it wouldn't electrocute you. But it's got to be pure water. If you have a solute that is an electrolyte, then that solution will definitely conduct electricity. So when we have a solute that's dissolved in the water that is an electrolyte, it conducts electricity because we have these ions, and these ions are passing along that electron throughout the entire solution, allowing electricity to be conducted through it. Now, one of the things you got to understand here is the more of the ions you have in the solution, the better that solution will conduct electricity. So if we have a strong electrolyte in solution versus a weak electrolyte, the strong electrolyte solution will conduct electricity better because there are more ions in that solution. A non-electrolyte solution, not going to conduct electricity at all. So if I have like sugar water and that's it, sugar and water, that solution will not conduct electricity. Again, strong electrolytes are going to be the best at conducting electricity as far as aqueous solutions go because they dissociate into ions 100%. Okay, so earlier we talked about, hey, we need to be able to tell whether an ionic compound is soluble or not to determine whether it's a strong electrolyte or a weak electrolyte. Now, how do we do that? We use what are known as solubility rules. And this is a table from an older textbook, but the rules don't change much between textbooks, if at all, really. So I'm going to keep using this table. Now, what I have highlighted in yellow here is what I expect you to know. I'm not going to provide this information on a test or anything. The rest of this information I will provide you on your exam. So I guess I should use a different color here. So what I have boxed in green here, This will be given on your test. You don't need to memorize it. All right. But what I have boxed in yellow up top here, this is something you need to know. So compounds that contain alkali metal ions, in other words, that first column of the periodic table, if there's one of those ionic or metals present in the compound, ionic compound, then it's going to be soluble. And if there's NH4 plus ammonium in the compound, also always going to be soluble. Same thing with nitrates, acetates, bicarbonates, chlorates, and perchlorates. If you have any one of those ions present in the ionic compound, doesn't matter what the other ion in the ionic compound is, that ionic compound is soluble. The rest of our rules, as you might notice, have exceptions. So for instance, halogens, if you have Cl-, Br-, I-, if you have them in an ionic compound, most of the time they're soluble, unless the cation is silver, mercury, or lead. With sulfates, again, most of the time sulfates are soluble. However, if you have silver, calcium, strontium, barium, mercury, or lead as the cation in that ionic compound, and sulfates the anion, well, those guys are going to be insoluble. Now, below in this bottom section of the table, again, these are all parts I'm going to provide you on the test, pretty much written exactly the same way. Carbonates, phosphates, chromates, sulfides, hydroxides, most of the time these substances are not going to be soluble. The exception is when one of them contains this group up top, then that's definitely going to be soluble regardless. Or in the case of hydroxide, if you have Ba2 plus present or that group up top, then it's soluble. All right, so that's it for this lecture video. If you have any questions, please let me know.